Hello friends and welcome to my electronics channel. In today's video we are going to talk about how to connect an RGB LED to a microcontroller like Arduino or ESP32 or a Raspberry Pi. So first let's see how the component looks like. So if you see here we have this RGB LED which has 4 pins. The pin number 1 is the red LED, pin number 2 is the common anode where usually we need to apply the 5 volt or the 3.5 or the 3.3 volt the voltage from the Arduino microcontroller. Pin number 3 is the green LED and the pin number 4 is the blue. So basically RGB combination along with the common anode, which is the positive terminal, which is pin number 2. Okay, on the right hand side, if you see here, we have shown how we can connect the various pins of an ESP32. In this case, I have used this ESP32 microcontroller to this RGB LED with the help of the resistors. So the resistors are used so that we can limit the amount of current flowing through the resistor and so through this LED, and we can make sure that the right amount of voltage is sent to the pins 1, 3 and 4 of this RGB LED. Okay, so in this case, as you see here, I am using this ESP32, and so if I show you the code here, I have used so 3 different pins of this ESP32, which is pin number 5, 17 and 16. So these are for the red, green and the blue LEDs. Okay, so I have like initialized the 3 pin numbers because I will be using these 3 pins in the ESP32 device. Then I have set these 3 pins as output pin. Okay, so both 5 then 16 and 17 have been set to output pins. Okay, and then what I have done here is I have set the various values with respect to the RGB combination so that we can see the various colored LEDs. So for instance, the first one, okay, I want to make sure the red LED is glowing. So I have set 255 value in the red, and in the green and blue I've specified 0. Okay, so similarly for the green LED I have specified 0 as the R, then G as 255 and then blue as 0. So likewise I have used various color combinations and then the RGB combination of values to create multicolor RGB combinations. Okay, and this is the common function RGB underscore color where the values get passed. So this red light value, green light value and the blue light value are being copied as to whatever values I am passing from the functions, and these are then set to the right pin number. So for instance, the pin number 5 is red, the pin number 17 is green and pin number 16 is blue. So these 3 pins of the ESP32 has been set with the right number of the values with the help of this function. Okay, with reference to this I would like to show you one color values. So it's pretty simple, like as long as you are aware of this RGB combination of colors, you can very well understand that passing 0 across all the values creates a black color. It's passing 255, which is the maximum value for each of the R, G and B combinations, create the white color, and then whatever you see are the combinations are the combination of the colors. They create multiple color combinations like this, okay, based on the values you are sending. So similarly, like just to give you one example, 128, 128, 128 is being passed as 3 values of RGB, which creates the gray. Okay, so for any applications of this RGB LED where you want to have or to achieve a specific color, feel free to use this kind of combinations. Okay, let's move to the working video and see how it works. So the moment I have run this code, so in this droid cam, as you see here, I have used the droid cam and I have executed this program here, and it is like glowing at an interval of 1 second because I have given a delay of 1000 millisecond here. So here is my ESP32 microcontroller, and the moment I've run this program, this is like blinking the LED with multiple color combinations, at an interval of 1 second. So this is for the delay of 1000 as mentioned over here. Okay, let me show one more program here. So this is a way by which I want to use the RGB colors as a fader. Okay, so what I have done here is I have used the same three pins 5, 16 and 17, and then I've created an LED array to create three different LED channels based on which I will be passing my values from 0 to 255 at a certain time interval. Okay, so using this, as you see here, this code is freely available in the public internet. We can set, so we can use various unsigned integer values for the color, the red, green, blue channels, and the brightness. Okay, firstly I am setting all the three pins to 0. Okay, and then with the help of these the setups, right? So basically we are using a 12 kilohertz pulse width modulation, so that is why we have to set the frequency as 12,000, and we are also using 8-bit resolution. So whenever I'm making a call to this LEDC setup inbuilt function, I have to pass these three values for the three channels. So this is basically how you initialize all the channels. It's a 16-bit channel where the resolution is 1 to 16, and the frequency limits are dependent on what kind of resolution you are passing into it. So that's my setup. Okay, inside my loop function, I have first set all the LED values to white, okay, which is passing the maximum value to 55. Okay, and then I have set all the values again, all the channel values to 0, which is black. So basically it's a blink, it's more like a blink, and I can actually specify a delay of 2 seconds in between. Then finally the fading starts, and as you can understand, inside the fading I have used it's more like a for loop here, where the color value starts from 0 with an increment of 2, and then it gets, the loop continues till 255, which is the maximum value. Okay, and I'm just specifying the three values of RGB, and then this function called is a local function called hue to RGB, where this color value is being passed along with the brightness parameter. So for the brightness, just refer to the same code here, okay, where I have used the brightness as 255. So what happens is it gives an it's more like a rainbow effect, where the color starts from 0 till the maximum of 255 in increments of 2. So it's more like a fading between multiple colors of the rainbow, and there's a delay of 200 milliseconds, so that the human eye can visibly recognize the various colors which are available over these 256 color patterns. Okay. So let's see what happens when I upload this sketch to the Arduino. Okay, just keep an eye on this page where it shows the blinking of the LED. Okay, and I'll refer to the compiling of the sketch. Okay, so this sketch is getting compiled, as you can see here. So it's compiling all the libraries, it's compiling the core, and then it's linking to all the internal libraries. Okay, and then finally it is connecting and writing all the contents of the code and reprogramming it. So as you notice here, the color is fading, okay, at an interval of 200 milliseconds, starting from this purple to blue. Okay, hope you can see here. So from the blue it is turning to green now, then gradually from green to yellow, from yellow to orange, then from orange to red, from red it is moving to violet, which is purple, and then the entire cycle of the VibGeo, the rainbow pattern, continues. It starts with magenta, which is purple, then blue, going to green, then gradually to yellow, then orange, red, purple again, then going to blue, cyan, green to yellow to orange, red, and to purple again. Okay, so hope you like this video. So if you found it useful, please like the video and subscribe to my channel, and thank you so much for watching.